Hello guys, welcome back and let us continue our discussion on this filter realization topic, and today we'll be taking the direct form 2 realization of IIR filter. So according to this we have completed IIR filter realization in direct form 1 in the previous lecture, and today's lecture will be taking the next one, direct form 2 realization. So for direct form 2 realization, once again we shall start with this equation, and here we have taken y of n, that is the present input. This is our present output. So this portion is the past output, and here we have the present and past input. Present plus past input. So this combination we have. So we are representing the these things in the z transform. So we are getting as y of z, that is equal to summation over k equal to 1 to n a k z to the power minus k, y of z, that is equal to summation over k to 0 k equal to 0 to m b k z to the power minus k x of z. So now we are taking z common, so what we are getting is 1 plus this thing, and here we have bk z to the power minus k x of z. So from here we can easily find the transfer function h of z as y of z by x of z, and accordingly if we are taking this to the right hand side, so what we are getting, summation over k equal to 0 to m bk z to the power minus k divided by 1 plus summation k equal to 1 to n ak z to the power minus k. Now you see, for direct form 1 our approach was different, and in this case approach will be a little bit different. So now what we are doing, we are taking this transfer function h of z, that is y of z by x of z, and here we are defining another transformed intermediate y of z. So basically y of n earlier also we have defined, here we are defining its z transform version, that is y of z, and here in the numerator and denominator we are multiplying the same thing, so meaning remains same. Now we are considering that w of z by x of z, that is equal to 1 by 1 plus summation k equal to 1 to n ak z to the power minus k, and y of z by w of z, that is equal to summation k equal to 0 to m bk z to the power minus k. So if we multiply this thing, these two, if we multiply this one and this one, if we multiply, then we get the previous form. So without disturbing our previous form, we are representing it in this way. So in equation 4 and equation 5. Now let us try to realize them separately. So equation 4, so this is what we have in equation 4, cross multiplying this, what we are getting, that x of z, that is equal to 1 plus summation k equal to 1 to n ak z to the power minus k. So this is my output. W of z I am considering as output in this equation, and x of z is as usual input, and similarly taking some part of the output in the right hand side, what we are representing as w of z as a function of x of z and w of z. So if we expand this equation, what we are getting, w of z, that is equal to x of z minus a1 z inverse w of z minus a2 z to the power minus 2 w of z, and so on. So now if we take inverse z transform, what we are getting, that w of n is a function of present input x of n and the intermediate function, past values of the intermediate function w of n. So that is w of n minus 1, w of n minus 2 up to w of n minus n. So now this equation 6 we are trying to realize. So what we are getting, that we have in this equation x of n. So we are giving x of n from here, and we have the delayed version of w of n. So at this point we are getting w of n minus 1, at this point we are getting w of n minus 2, and so on up to w of n minus n. So these values we are getting from here, and the multiplication factor, you see that here we have minus a1 minus a2 up to minus an. So that is what we are using as the multiplication factor and adding them up. So this entire thing, this entire structure is giving us the realization of this equation 6. Now similarly, let us take that equation 5. So equation 5 is very much straightforward. So y of z by w of z is this. So in this equation we are considering y of z as output and w of z as input. So expanding this, what we are getting, y of z equal to b naught, w of z, b1, z inverse w of z, and so on up to bm z to the power minus m w of z. Now if we take inverse z transform, so what we are getting, that output y of n is a function of the present and past values of wn. So b naught, wn, b1, w. So like that, let us consider this as equation number 7, and let us try to realize this thing. So y of n is my output. Here we have the output, and this is straightforward, is a function of w and its delayed version only. So at this point we are getting w of n, which is having b naught as its coefficient. So similarly here we have b1, b2, and so on up to bm, and then we are adding them up. So we are getting y of n. So this figure 1 and figure 2, now if we combine, so if we combine this figure 1 and figure 2, so for that we have to follow few things. Like we find that the same delay terms means w's, wn n minus 1, wn minus 2 up to wn minus m are used to express wn and y of n. And also we find the delay elements in figure 1 and figure 2. They are having the same input and same output. If you look back here, if you see that this delay element z inverse is having input as wn and output as wn minus 1, and in figure 1 also you see that this delay element, first delay element, we are having input as wn, output as wn minus 1, and so on. So if the delay elements are having the same input and same output, then we can easily merge figure 1 and figure 2 as using only one delay element. So we need not to use two different delay elements. So in this structure we need m plus n plus 1 multiplications, m plus n additions, that means here we need to use multipliers, here we need to use adders, and the memory locations, that is delay elements. So how much we need? We need maximum of m and n. So whichever is higher, that many delay element we require. So since this realization minimizes the number of memory elements, so which is very critical, especially in digital devices, and it is said the canonic form. So if we merge figure 1 and figure 2, so we are getting this figure. Here we have w of n. So at this point we have w of n minus 1. So at the input side as well as at the output side we can utilize them. So that means by tapping from here w of n minus 1, both in the input side as well as in the output side we can utilize them. Similarly this output we can utilize, and this will go on say up to n. w, at this point we are getting wn minus n. Okay, so that we are taking at the input side. Similarly, but we cannot stop here because we need to have up to m values. So m number of z inverse, that is delay element, we require. We have considered in this case m is greater than n. We can have it other way also. So whichever will be higher, that many delay element we need to use. So here we are using the multipliers for the different coefficients, and finally we are getting the output y of n by merging figure 1 and figure 2. So this realization is called direct form 2 realization. Now if we take the same example, if you refer our previous video for direct form 1, you will see that same example we have solved there using direct form 1. So here we are taking the different approach, and here we are taking the z transform of this given equation. So we are representing it in the transfer function form, that is finding the h of z, y of z by x of z. So this is what we are getting. Now we are dividing h of z, or writing the h of z in this form, y of z by w of z. So this is one part and this is the another part, and w of z by x of z is denoted by 1 divided by 1 plus 2r cos omega naught z inverse plus r square z to the power minus 2. So these are just the coefficient, so don't get frightened with this. Here in this in place of this you can have some any numerical value 1 2 3 4 0.1 0.2, so this kind of thing you can get. And if omega naught and r, these values are given, you can also calculate some numeric value for these things. So these are some tricky questions, somewhere you may get this kind of representation also. So anyways, we are now defining y of z and w of z, y of z by w of z as this thing, numerator only. So if we multiply these two, we will be getting 1. Equation 2 and 3 if we multiply, we should get equation 1. That is the concept here. So now let us realize them separately. So w of z by x of z, cross multiplying, what we are getting is x of n, that is equal to w of n minus this thing. So you can take w of n in this side and x of n in this side. So then we will be representing w of n in terms of x of n and the previous values of, or previous values of w's, that is w n minus 1, n minus 2, up to n minus 2 only we have. So 2 delayed version of w we have. So we will be using 2 delay elements here. At this point we are getting w n minus 1, and at this point we are getting w n minus 2, and my coefficients are minus r cos omega naught. So this one the minus 2r cos omega naught and r square. So these are the two coefficients we are getting, adding them up. So we are getting wn. Okay, so at this point we have wn. Now instead of giving arrow here, we can give arrow here. Okay, and then the second equation, y of z by w of z, that is equal to 1 minus r cos omega naught z inverse. So we have only one delay element here, or delay value z inverse. So we will be using only one delay element, and by taking inverse z transform, we are representing y of n in terms of w of n as a function of w of n and w of n minus 1. So only one delay element we are using. So here we have w of n, which is not having any coefficient, you can see. So not having any coefficients means 1. So you can draw it in this way, or you can put like this. Both are correct. And the second case, we have this as the coefficient, so r cos omega naught. So this is my figure 2. So figure 1 and figure 2, now if we combine them, so here if we consider this as your system, x of n is the input and y of n as the output. So avoid this arrow here. Okay, better to use arrow in this direction. Okay, so what we are getting, that this is the feedback portion here. At this point we are getting w of n minus 1. W of n minus 1 is there both in the input side as well as at the output side, but they are having different weight, 2r cos omega naught, minus 2r cos omega naught, and minus r cos omega naught. So these are the two different ways we are having, and here r square we have the another one. So this is the total combined figure for the direct from 2 realization of the given problem. So here it ends, and you can take some more typical examples, like these are the reference that I have followed, especially in reference 5 and 4. Here you will get lots of solved numericals, so I urge you to go through those solved numericals. That will clear your concept better. So thank you very much. We end here, and the next lecture will try to realize this in cascade form. So cascade form is nothing but we are dividing the equation in the smaller part and realizing them accordingly. Separately we are realizing them, then we are combining them. So we can use either direct form 1 or direct form 2. So we will be discussing that in the next lecture.